Hi, today we're going to be looking at ellipses. So yesterday we talked about circles, and you'll notice some similarities between our circles and ellipses today. Now at first glance, an ellipse kind of looks like an oval or a smooshed circle. So we either squashed it down or squashed it in from the left and the right. Now there is one new piece of vocabulary with this. It's called a focus, or foci if it's plural. And it's two fixed points inside. So those are those red dots that you see on the screen there. Those are the foci of the ellipse. And if you were to take any point on the circle, okay, let me use my highlighter here. Let's say I chose this point and see how it connects down to each of the foci. If I were to take those two lengths, add them together, I'd get some sort of number. And let's say I took another point on our circle. Let's say I took this one down here. So I'd be looking at this and this. That point connected to those two. If I added those two green lengths together, it's going to equal the sum of those yellow lengths together. Okay, so the sum is equidistant or the same for any point on the ellipse. So some other things, an ellipse does have a center. Okay, and the pictures here, the center is at 0, 0. It's at the origin. Okay, and we have something called a major and a minor axis. So a major and minor axis is almost like a diameter, kind of seems like that. So looking at this first one here, the horizontal ellipse, this line there that I highlighted would be the major axis. On the vertical axis, the vertical ellipse, it's going to be this value here. Okay, it goes up and down. So the major axis is the furthest away, or that longest length across our ellipse. Then we have a minor axis, and as you might probably are already thinking, the minor axis is that shorter length. So on the horizontal, it goes up and down, and on the vertical one, it goes left and right. Okay. Now at the end of those axes are either vertices or co-vertices. And remember, singular is vertex. Well, on these we have multiple vertex, so it's vertices. So the vertices are the ends of the major axis, and the co-vertices are the ends of the minor axis. And typically we're going to use A's when we're dealing with the major axis and B when we're dealing with the minor axis. Okay. So on this page we have a lot of helpful information, or a good place to look at for information about our ellipses, if they're centered at 0, 0. Next week we are going to look at it when it's not at 0, 0, but for right now all of our ellipses today will be at that center of 0, 0 at the origin. Okay, so let's talk about horizontal ellipses first, which is that first column here. Okay, so our equation is x squared over a squared plus y squared over b squared equals 1. One thing to note here too is that a is greater than b and it's greater than 0. So a and b are those distances from the origin out to either the vertice or co-vertice. Like I said, a goes with your major axis, b goes with your minor axis. And since a has to be bigger than b, notice the a is underneath x. So we can tell if it's horizontal or vertical by which denominator is larger. So the larger denominator is going to be beneath the number that's going to be the major or minor axis. And back to the horizontal ellipses. The vertices, notice, are plus or minus a comma 0. Co-vertices are z comma plus or minus b. I'm going to stop about the foci. We're going to hold off on that for just a minute. Vertical ellipses, x squared over b squared plus y squared over a squared equals 1. Notice the a and b have switched because now a, like I said, goes with your major axis. It's underneath y. And if we have a vertical ellipse, the y is our major axis. It's vertical, up and down. So our vertices are 0, comma, plus or minus a. Co-vertices are plus or minus b, comma, 0. Now our foci, notice that your foci, here we have C, oops. Here we have our plus or minus C. And notice it's in the same position as our A. So if A is in the x coordinate, then C is also going to be your x coordinate. Over here, plus or minus A is our y coordinate, plus or minus C is your y coordinate. Now when we're dealing with this, okay, and you're looking for the foci, there's a formula that we're going to use for this. And it's very similar to the Pythagorean theorem. It's going to be c squared equals a squared minus b squared. So since a is always larger, a squared minus b squared is always going to be a positive number. So we can use this formula to find the foci if we need to. C squared equals a squared minus b squared. So here we have a problem completely worked out for us. And we're asked what is an equation in standard form of an ellipse centered at the origin with vertex -6, 0 and co-vertex 0, 3. So when we go to set up problems like this, I'm not going to really worry too much about A and B. So that's our standard form. Like I said, I left off the a squared and the b squared. Notice that -6 is in the x spot, or x coordinate. So it's going to be -6 squared here. And really, you don't even need that negative. You could just leave it as 6 squared. And then the 3 up here is our y value. So we'd have 3 squared. So 6 squared is 36. 3 squared is 9. So that's where we get this equation here. Now, if we were asked to graph this, we could go ahead and graph those 2 points given to us, -6, 0. So go ahead and put that point on here. And 0, 3. So that's up here. Now, since it is an ellipse, we know there's going to be a point over here, 6. That's the other vertex. And then we'll also have a point down here at -3. And if we were to connect those, oops, my 6 disappeared. It's going to look something like that. A little bit off, but that's kind of get the idea of what it would be. Okay, so we're going to try this again. And I know my words got cut off a little bit there at the top. What is the equation in standard form of an ellipse centered at the origin with vertex 0, 5 and co-vertex 2, 0? So when we go to do this, our 5, notice, is in our y value. So when I have my equation, x squared plus y squared over something equals 1. The 5 is in my y value, so I'll have 5 squared underneath the y squared. And the 2 is in my x value, so I'll have 2 squared that goes underneath x squared. So when I simplify this, I get x squared over 4 plus y squared over 25 equals 1. This would be our equation. Now, if we were going to graph it, okay, we can use those points given to us. So 0, 5 is over here. That means we also have -5, 0. Oh, I'm sorry, I went the wrong axis there. Okay, should have been on my y-axis. So at 0, 5, and down here at 0, -5. And then we also have a point at 2, 0, and -2, 0. If we go to connect that, it looks something like this. Okay. Notice it's taller and not as wide. Okay. Now this can be a tricky question here. Find equation of an ellipse in standard form with center at the origin and with a height of 50 feet and width of 40 feet. Now you might be thinking, okay, height is with their y value, so it has to be y squared over 50 squared. But 50 is the distance from the top to the bottom. So it's really only going, let's say these are in terms of tens, really only going up here to 2.5, put a little x there, and going down to -2.5. So it's really 25 underneath our y squared. Let me erase that. And then for our x, instead of being 40 squared, from one edge to the other is 40. So it's really half of that. So half of 40 is 20. So 20 squared. Okay. And we go ahead and square those. So if we square those, we'll have x squared over 400 plus y squared over 625 equals our 1. So this would be our final equation. Okay. Now sometimes we're not so much asked for the equation as to find the foci of that particular equation. So in this instance, we have what are the foci of the ellipse with the equation 25x squared plus 9y squared equals 225. Graph the foci in the ellipse. Well, first we have to take this equation and put it into standard form. Now in standard form, the one we've been dealing with so far, it was equal to 1. So we had to divide both sides by 225. When you do that, you get this equation here. X squared over 9 plus y squared over 25 equals 1. Now to figure out the foci, we're going to use our equation here. C squared equals a squared minus b squared. And remember, a squared is always bigger than b squared. So 25 is larger than 9. So of 25 minus 9, we get 16. That's equal to c squared. So to find c, I'm going to take the square root. So we get c is plus or minus 4, since 4 is the square root of 16. Now notice the largest number was underneath y. So that means our c value is going to go in for y. In other words, x is 0. So 0 plus or minus 4. That would be the point of the foci. And then over here on the right is a graph of this. And notice those foci, the ones in red, are on the major axis. That should always happen. One last example. Okay, what is the standard form equation of the ellipse shown? So this time they're giving us the foci and the major, or the vertices, the endpoints of that major axis. So we know that it's a horizontal ellipse, since it's larger that way. Our foci are on the major axis. So we're going to use our c squared equals a squared minus b squared. Well, c is obviously 5 plus or minus 5. So 5 squared is 25. So we'll plug that in for our c here. A squared is going to be that negative 8 squared, or 8 squared is 64. So now we have 25 equals 64 minus b squared. We'll have to subtract 64 from both sides, subtract by negative 1, and we end up with b squared equals 39. Now technically you do not have to figure out what b equals, because the equation is x squared over a squared plus y squared over b squared equals 1. So we just found out that a squared is 64, that plus or minus 8 squared is 64. We can go ahead and just substitute in that 39 for the y squared. And so we end up with x squared over 64 plus y squared over 39 equals 1. Okay. So that's the end of our notes for the day. As far as your homework goes, there is an assignment up on Math Excel over ellipses. I'd like you to take some time to go over that. If you have questions or comments, leave them on Google Classroom, or you can go ahead and email me. I'll have office hours 8 to 10 a.m. Monday through Friday, and I'm hoping to set up a Zoom or a Google Meet in order for us to talk if we need to. Have a great day. Bye.